So this is a Brookfield Viscometer. So the name itself, and what is the purpose of this equipment? Viscometer. So which is used for viscosity measurement. So which is used to measure the viscosity of pharmaceutical dosage forms. So mostly the dosage forms like liquids, syrups, suspensions, emulsions, and semi-solids like creams, gels, and other liquids and semi-solid dosage forms. The viscosity will be measured by this Brookfield Viscometer. So what is viscosity? The viscosity is one of the physical parameter which indicates the stability of dosage forms. So if you want to test the stability of some of the dosage forms, we use the viscosity is one of the physical parameters. For example, suspension or emulsion. So whenever in case of suspension, viscosity is more, the rate of sedimentation of the particles will be less. So to know the stability of any dosage forms, most of the dosage forms, we use the viscosity as one of the physical parameter. So here the viscosity will be measured by number of viscometers. So in last class we also done Ostwald viscometer. So similarly we have falling spear viscometers, cup and bob, cone and pade viscometers. So this is the another equipment, Brookfield viscometer, used for the measurement of viscosity of liquids and semi-solid dosage forms. So here the Brookfield viscometer is a rotational type of viscometer. It is a rotational viscometer. Why it is known as rotational viscometer means it consists of here there is a rotating spindle. So it is rotating in a circular motion. So it consists of rotating spindle. So here the spindle will measures the resistance offered by the sample towards the rotation of spindle. So here what is the principle behind? So the viscosity is measured in terms of, the viscosity will be measured in terms of the resistance offered by the sample towards the rotation of the spindle. So if viscosity is more, the rotation of the spindle will be less. If the viscosity is less, the rotation of the spindle will be more. So like that we can measure the viscosity of the dosage forms. So here whenever there is a resistance offered by the spindle, it will give the signals in the form of torque. So it will produce the torque on the measurement. It will produce the torque on the surface of the sample. Now this torque will be given to the signals to the instrument, and then it will display the viscosity in terms of centipoise. So here the basic principle will be the resistance offered by the sample towards the rotation of the spindle is measured. So it will be produced in terms of torque on the surface of the sample. Sample యొక్క surface మీద torque produce అవుతుంది. Now this torque will be measured in terms of viscosity in the units of centipoise. Okay, so coming to the instrumentation, so it's mainly the model is LV model, LV Brookfield Viscometer. So what it indicates means, LV means lower viscosity, so which is suitable for lower viscosity. That means a lower torque configuration, which indicates here the LV will indicate lower torque configuration. That means which is suitable for lower viscosity samples. Mostly in case of laboratory scale we use the LV models, whereas in industrial scale we use the RV model. So we are also having another models like RV, which is known as a regular viscosity model, which is used for high viscosity samples like semi-solids, gels, creams, ointments, paste, suspensions, like that we use a RV model. So mostly that will be utilized in a industrial scale, whereas in laboratory scale we use the model of LV, which is suitable for lower viscous liquids. So coming to the parts of this instrument, which is mainly the display. The display part will be there. Here there will be a display. Here the display will be present, which indicates which gives that what are the different parameters were set. which display the various parameters. And here this total will be control panel to operate the instrument. So here there are the buttons will be there, number of buttons, motor on and button, enter, set the speed, set the spindle, and whereas printer option is also there. So if you connect this equipment to the PC, computer connect cheste, we can take the results in the form of printouts. So print option is also there. Automatic in industrial scale we also use it for our automatic purpose to take the printouts. So here this is the control panel to operate the instrument. And the next thing is this is a spindle coupling unit. So what it consists means, here it consists of motor, spindle coupling unit and so it consists of motor. So to this motor, here there is a shaft will be present. So inside this coupling unit there is a motor. To that motor there is a shaft will be present. To that shaft we are attaching the various spindles. Okay, na? So next one is spindles. So here to this coupling unit we are attaching the different types of spindles. So mostly we have a 4 or 5 different types of spindles we have. You know that first one is a cylindrical type of the spindle, and the second one is a disc type of the spindle, and third one is cone type of the spindle, and the fourth one is a T-bar, T-shaped spindle, and fifth one is spiral type of the spindles. So here to this coupling unit we are attaching the various types. So based on the sample we are attaching these spindles. So we have cylindrical, disc, cone, spiral and T-bar types. And mostly these spindles will be indicated by the different numbers, LV1, LV2, LV3, like that we are indicated LV7, LV21, 27, 28, 29, based on the torque which is produced by the spindle. So we are going to select these spindles based on the whatever the sample we are going to be test. And here this is a sample holder. So inside this we are placing the sample, a small quantity of the sample which is going to be tested. So a sample యొక్క viscosity measure cheyalo, so that sample need to be placed in this sample holder. And here it is an advanced type. This sample holder is also having a jacket. If you see this, here there is a jacket. So mostly viscosity will be affected by the temperature. We know that whenever the temperature is high, viscosity will be reduced. Whenever the temperature is low, the viscosity will be high. So one of the major parameter which is affected by the which affect the viscosity is temperature. So we need to maintain the constant temperature while we are measuring. We need to maintain the constant temperatures. So that's why here there is a water jacket, and here we can connect the water circulations. We can also connect. And now, so after placing this, we can connect to this here. This we can place the sample holder. So here initially coming to the operation, so here first switch on the instrument. So we need to see that whether the instrument is properly leveled or not on a platform. So now we need to switch on the instrument. Here there is a back side, there is a switch will be there. So we need to switch on the back side button. And now we have a different parameters. So external mode and standard mode, always we are using the standard mode. So standard mode, now press the enter. So and leave the instrument for initialization. So it will check all the parameters, RPM, all the things will be in a proper condition or not. So here leave some allow the instrument for initialization. Then there is a display of remove the spindle and press any key. So now we need to select a specific spindle based on the sample, and we can attach the spindles. And after that we need to set the speed of the spindle, and before that we need to making the instrument auto zero before the measurement of any samples. So if you press any key, it will automatically make the instrument auto zero. So before the instrument of any samples, we make the instrument auto zero. Then we have to set the parameters. So if you see here the display, the first option will be centipoise. The viscosity will be measured in centipoise, and here there is a temperatures 32.9 degrees centigrade, and here this will be RPM. Now it is in off mode, so RPM will be displayed here, and here this is the torque which is produced while it is rotating. So how much torque, how much percentage of the torque it will be produced. So the display buttons will consist of viscosity in centipoise. Directly we can note down the viscosity in centipoise. So digital parameters. So here next one is temperature and RPM. So now set the speed. So RPM 60. We can make 20, 50. So now the RPM will be set to 50 RPM. Now enter the button, enter. So if you see, when the motor, here there is a motor on and off button, when the motor is on. So if you see here, there is a, the parameters are moving, right? So if you see here, the viscometer, the spindle is rotating, and remaining same procedure. We have to switch off the instrument and switch off the all the operators and clean all the operators. So this is about Brookfield Viscometer, mainly used for measurement of viscosity of the liquids or semi-solid preparations. So it is a rotational viscometer. That means it consists of rotating spindle, and it produces the resistance. It offers the resistance to the the spindle based on the resistance offered by the spindle sample. It will produce the torque. So the torque will give the signals to the recorder, and it will display, the instrument will display the viscosity in centipoise. That's it.